Now we will move to our final workshop for today by Dr. Hilmi Muhammad Hadi Pritam from School of Health Sciences, University of Science, Malaysia, Kubang Krian, Kelantan. Dr. Hilmi Hadi started his field in academia by obtaining a BSc of Health Sciences in Forensic from University of Science, Malaysia. He then obtained his master's in human identification in 2008 and PhD in life sciences in 2012 from the University of Dundee, UK, specializing in forensic anthropology. Currently, he is a lecturer at the School of Health Science, University of Science Malaysia, teaching forensic science undergraduate and postgraduate courses. His main research areas are facial reconstruction, science undergrad, forensic anthropology, and geometric morphometrics. Previously, while in the United Kingdom, he was a member of the British Association for Human Identification, (BAHID), and currently he is the member of the Forensic Science Society Malaysia (FSSM) and a lifetime member of the Malaysian Anatomical Association (MMA). Without further ado, I would like to invite Dr. Hilmi Muhammad Hadi Pritam to present on new methods in forensic anatomical research. Over to you, Dr. Hilmi.
Yeah, thank you for the invitation and thank you for the introduction. I'm going to share my screen now. Hopefully you can see the PowerPoint screen. Okay. Okay, I'm assuming now everyone can see the screen right now.
Yes, absolutely.
Okay. Okay, so the topic given to me today was new methods in forensic anatomical research. I'm Helmi from USM. So what is going to be covered in the term? So I'm going to cover about some of the terms used in forensic anatomical research, the anatomy in general, parts of forensic interest, and research regarding those parts. So who is this lecture or this talk for? So if you are interested in doing research in anatomical or forensic field, but you do not know where to start, so I'll tell you about the general anatomical tools and the techniques, conventional and current tools, and ethics and issues regarding forensic anatomical research in Malaysia and in the world. So there are a few terms. I will just summarize all these 4 terms. So basically, forensic is from the Latin word forum, meaning marketplace. Anatomy is a branch of morphology which deals with organism morphology. And anthropology is study of people, especially their history, their culture. So when you're taking forensic and anthropology together, what you get is actually a very subspecialized field. So if you Google forensic anthropology, it will come out with 2 results. One is the anatomical aspect, the bone. One anthropology is the cultural aspect. So be careful or determine. So sometimes it may come out archaeology, sometimes it may come out anatomy. So it depends on what you are looking for. So in general, most people in medicine and health sciences will refer to the Gray's Anatomy book, which tells us all about the anatomy. So it is not that Gray's Anatomy TV show. Even though the spelling is different, it sounds the same. So why do we refer to the anatomy book? Is because we want to see the cause of death. We want to determine the cause of death. Either it's natural or unnatural. If it's unnatural, are there criminal case or is it just due to negligence? So the human body in general is made up of a lot of items. So from a cellular level, you can see that it's all individual cells which combine to make a tissue structure towards an organ and finally towards a system, organ system. And the human body is made out of soft tissue and organs and also the hard tissue and muscles. So and all of these are of use for forensic anatomy research. From the skeletal aspect of the human body, we can see that from the entire skeleton, you can get stature either from the entire skeleton or parts of the skeleton, You can also determine the disease. From the bones, you can tell whether a person has rickets, whether there is a vitamin deficiency. You can x-ray bones to determine the age. And you can also, from the bones, by looking at it, you can determine whether the person has a lot of stress in his lifetime. And stress will wear the bone and will cause bone reabsorption in some places. And race and DNA as well can be known from the bone. If you're looking at the skull in general, we can determine the race, sex, and we can also do a reconstruction and superimposition. So this is more towards the skull. When we are looking at the pelvis, we can determine the sex and age. Race, yes, but not that much. And it depends on the subclass of population. Now we are going to the soft tissue. And when we are talking about the soft tissue, we need to note that the soft tissue is important. And why is it important? Is because we can get a lot of items as well. From the skin, we can conduct injury analysis. So injury analysis is important in forensic science because it can corroborate the weapon. So it can help in crime reconstruction. You can determine based on the wound whether the weapon is a sharp weapon, whether it's just a laceration. There are a lot kinds of wound characteristics which can be noted from the skin surface and the layers of the skin. When we're looking at the skin surface as well and the dermis and epidermis, we can see that we can also tell the burn structure or the burn percentage. We can define that whether someone lives or dies. Usually we base it on the rule of nines. So based on the rule of nines, we can say that this is first degree, second degree, and third degree burn. Some people may say that there is a fourth degree burn as well. Aside from that, from organs, we can identify whether there are injuries, whether there are necrosis of the organs, whether we can do also toxicology analysis from the blood samples, from the urine samples. If we are just looking at the nails, what we can do is that we can see traces of heavy metal deposition. For example, if someone is ingesting heavy metals chronically for a long period of time, the heavy metals will secrete or exit the body through the nails. So this is useful for poisoning. Also from the soft tissue and hard tissue, we can get DNA. So what are the tools? So I'm going to talk first about the conventional tools, methods, and issues. So previously or still currently, we use calipers in forensic anatomy. The reason why we use calipers is because it is very easy to get linear dimensions. Linear dimensions can be obtained on living individuals and deceased. We just take the caliper or a ruler and just put at different places on the body and just measure. And from that measurement, we can do all kinds of inferences. So you have a spreading caliper, sliding caliper, and coordinate caliper. The coordinate caliper here is just for projection measurements. For bones, we can use the Martin's needle to put the skull in a FH plane, or Martin's diagraph to measure the skull contour, or the Martin's dioptograph to make an outline of the bone. Out of these three instruments, we still use the Martin's horizontal needle. The Martin's diagraph and the Martin's diptograph we do not currently use because there are newer methods which replace these methods. And the equipment itself is actually quite bulky. For the Martin's horizontal needle, if you are dealing with physical skulls, it is easier, and we can construct this Martin horizontal needle with the use of a clamp, a skewer knife, and just a skull stand with the skull. These other two machines are very specialized that they are now in museums. Other conventional tools we have also include mandibulometer. So the mandibulometer is mostly used by the dentistry group. So when we're looking at the mandibulometer, the dentistry group will use the mandibulometer to measure the angle of mandible. The angle of mandible can tell you the sex of a person. based on how masculine or how feminine the jawline is. The Reed's osteometric board here, the picture in the center here, this board tells you about the length of an individual bone. So if you take a bone, you put a bone here and it just measures the absolute length. This board is still being used today for bone measurement. If it's not being used today, it may be placed in your anatomical museum, in your university, or in your hospital. Finally, we can also use measuring tape for taking measurements. And when we are dealing with conventional tools, usually some measurements are taken at the autopsy table itself. So during autopsy is when the doctor and the scientists and the people involved will help in making measurements and documenting the procedure. So on the right here, you can see that all the various instruments you use during the cadaver dissection. So currently, we still use, aside from your dissecting table, we use our GCMS machine and HPLC machine. So the GCMS and HPLC is more for trace element analysis. Usually for your urinary fluids or your bodily fluids, we can use our gas chromatography machine, or we can use the high performance liquid chromatography. And the peaks, we do inferences based on the peaks shown there. Next is the genetic analyzer. This is for DNA. So usually we can get any sample from the body. If it's an old remains body, we will need to drill or get it from the bone, maybe from the third molar, a CT, and that are the results. So you can see the peaks below here. The peaks here shows the results of the DNA analysis. CT scans or MRI will give you the internal structure of the cadaver or of the human being. So CT scan, MRI will just, CT scan is for hard bone, hard tissue, and MRI is for soft tissue. X-ray is just like CT scan, it can do for both, but mainly it just gives you a 2D representation of the person. And usually for X-ray, the most people will come towards X-ray is when they are doing their medical checkup. And you need to hold your breath so that a chest X-ray can be conducted. So for conventional methods, aside from measuring with your tools, we can also use qualitative analysis. Qualitative analysis is very easy compared to quantitative, because qualitative is morphology based. And when it is based on morphology, what we can see is that we can tell things easier just by looking at it compared to by measuring it. So for example, here is a skull. Here are two pieces of skull, a male and a masculine and a feminine skull. So on the top there is a male skull, and the bottom is below it is a female skull. From the bregma, from the glabellar region, the occipital region, and the mastoid region, we can tell whether the skull is masculine or feminine. We can tell just by looking at the skull whether this skull belongs to a male or female. And this skill is not just exclusive for forensic anthropologists. Normal people will use their experience to determine whether this person is a male or female, especially when you have cross-dressing individuals, or you have people who try to imitate or try to go towards the opposite sex. So when you look at the face, you may say that this face may look female, but when you look at the body, it doesn't show a female body, it may show a male body, and vice versa. So qualitative methods of assessing bones is easy to do, but it is hard to capture with conventional measurement tools. So conventional methods, we still rely on all the methods, either qualitative or quantitative, because of law requirements, especially for service-based. So for those who are in the Ministry of Health, they need to do the postmortem. And it is cheaper compared to newer methods. A physical dissection of the human body is still cheaper compared to a virtual dissection, simply because the machine for virtual dissection is very expensive. The science needs to be very sound, and it must be repeatable. So most of the literature is actually for conventional analysis compared to newer techniques. So qualitative methods can be accepted in court. And it's easier to explain to a person, if you are looking at this bone, this is what to look for. Right? Quantitative methods are also useful, but it is more useful for publication purposes. Because for quantitative journal papers, sadly or ironically, they like numbers. And with numbers, you can publish a lot of data. The problem when we are dealing with samples or physical samples is that when we are dealing with samples, we have physical samples where we have few problems. The first problem is sampling. Where do we find the bones or the tissues to do the sampling? When we get the bones or the tissues or the fluid, where are we going to store the samples? That is another problem. After storing the sample, what about the safety? If it's in a controlled environment, for example, in a government hospital, then security, safety, and storage may not be a problem. And then if it's of item of value, for example, in an excavation site or a site where mass murder or mass burial has occurred, then thieves or maybe scavenger animals may be interested in the bones. So degradation is an issue for older specimen. And then and we do not know also the safety of the people involved. Safety of the people involved when collecting the specimen in the field. We do not know that the ground or the surrounding area is contaminated, and that contamination may affect the people collecting the samples. And finally, with all these three F's in place, we have the cost. Cost is actually a very big problem when we are conducting experiments or when we are collecting physical specimens, because cost involves in all parts of the procedure, from sampling, storage, and safety. And sometimes because of cost, we cannot do a lot of sampling, or we need to choose our sampling method or sampling references. So for the new methods, I'm going to talk also about the ethics, sampling, and analysis. So the techniques for the new methods, I'm going to talk about the safety, storage, and cost. What is not covered in this part of the lecture is the equipments. So how to use the GC, or how to use the HPLC, or how do you do your to extract urinary fluid, or how you take the bone is, I assume that you already know if you're already working in your Ministry of Health. But the new methods I will cover. And case studies and one-off findings which cannot be replicated, I'm not going to talk about mostly in this lecture. So the ethics. The first thing when you're doing ethics in forensic anatomical research is that this is the first thing you need to do actually, not the last thing when you want to publish your paper. The reason why is because you need to apply for ethical approval. Nowadays, we no longer accept ignorance as reason of not applying ethical approval. So you can apply your ethical approval from universities or from the Ministry of Health. There are a lot of bodies in Malaysia which are approved, which you can apply ethical approval from. So ethical approval helps you in a lot of aspects in your research. It helps you in your sampling, because it helps you in determining your sample size. The ethics committee will look at your ethical requirements and say whether your sample size is enough or not enough, whether you need to collect more, whether the safety, the storage, and the cost, everything, they will look under the ethics approval. And then recruitment. And then publication will require a code from the ethical committee or the ethical body, which issues the code to you. So ethical approval is not retrospective. We get this a lot. As a member of the ethical approval committee in USM, we get this a lot, and we cannot say that we cannot give ethical approval for something which has already been conducted, because it has to be before. You need to follow the guidelines before. So a lot of researchers, actually for first-time researchers, they fall into this trap when it comes time to publish, because the editor of the journal will email you asking, do you have your ethical approval code? At this point, now you will be very stressed out, and you will contact all the ethical bodies to acquire the code. So in generally, we can divide the research into two clusters, either retrospective or prospective studies. It is easier to get ethical approval for retrospective studies compared to prospective studies. It is not impossible, but it's easier because for retrospective, you are looking at available data sets compared to prospective, where you need to go out and collect data. So when we're talking about conventional and new methods, autopsy in Malaysia, we still rely on the conventional methods of autopsy. The reason why we rely on the conventional method is because of the cost or the barrier needed for digital autopsy. Digital autopsy is very nice because once you can do digital autopsy, you just put the body there and it just scans the body and you can immediately store or dispose of the body. But in Malaysia, we do not have the means yet for digital autopsy. The good thing about conventional autopsy is that it trains the surgeon or forensic pathologists to be very skillful at their jobs. For both conventional and new methods, we will get 2D and 3D data. So 2D data we can analyze with, or we can capture with image J, for example. So if you have a lot of 2D data, you can do analysis in image J. So Fiji is also image J or Morpho-J. For 3D data, we can also use a lot of either items, and we need, before we do collection on 3D data, we need to collect 3D data. And collecting 3D data, we need to rely on either surface scanners or photogrammetry. A surface scanner is expensive compared to photogrammetry. The problem with photogrammetry is we need to rely on non-moving objects. If you have a living object or living individual or animal, and the animal is not static, then photogrammetry is not suitable. You may want to go with a 3D scanner. So why measure or remeasure? Traditional morphometrics, as I've shown previously in the previous few slides, where you measure the length, height, and depth, are limited. Limited meaning you can only do so much with the data collected. However, with that same data, just because you have limited data doesn't mean you cannot do new analysis. So when you remeasure, we do not remeasure the, for example, this picture here, we don't remeasure the nose. We remeasure parts which cannot be measured with conventional instruments. So the outline of the nose or the projection of the nose cannot be measured with conventional instruments, but it can be measured with newer techniques. So the newer techniques which we can measure this kind of outline or the surface region here falls under geometric morphometrics. So geometric morphometrics, the easiest definition is just a fancy method to measure objects. This fancy method requires tools, capture, and some software to just put some points and you get some quantitative or and sometimes qualitative data. And with that quantitative data, you do your inferences, or you can sum up what you see from that region. So geometric morphometrics. So let's say I have this maple leaf here. It takes all your maple leaf samples, it stacks the maple leaf all together, and from that stacking and movement and scaling of the maple leaves so that it all becomes one nice object, it gives you quantitative results or statistical analysis. And from there, you can do newer analysis with your current data set. So what we can use it for? We can use it to answer about how parts of the body vary, how it responds to growth, evolution, injury, and how you control body parts. Race, sex, age, we can use geometric morphometrics. It finds the class shape and enhances the minute difference in the class shape. So it gives opportunity to researchers to visit old items or old data and for new analysis. And when you revisit old data, you can come up with all kinds of measurement based on the same data, based on whichever region which interests you. For example, a skull can be landmarked a lot of times, depending on the region of interest. I can have one skull. I can measure the pointedness or the angle of the mandible is one part. I can also use the mandible. I can measure the protrusion of the mandible. I can also use the mandible for the height mandible to correlate with stature. From the mandible, we can see whether there is bone reabsorption. So all these kinds of method we can use just from one data, we can get a lot of analysis. And this is useful for research. So it tests your experience. So because journals likes to the statistics and figures, it helps you in publication. Previous assumptions which you cannot prove previously, but you have a hunch, you can use geometric morphometrics to test your hypothesis. For example, racial group. Does the scapula in Malay, is there a difference in scapula morphology for Malay, Chinese, and Indian population for the Malaysian population in general? So sampling techniques. So we make use of virtual and collected specimen and real specimens. So always have from your original specimens, what you have in your original specimens, your linear measurement will always be a measurement between two lines. So these two measurements will only give you a linear. So you only have a between PC1 and PC2. So, but as we move forward, we have shape or thin plate splines. So shape or thin plate splines makes use of similar landmarks for a location. So it compares between average landmarks for a given location. And then we move forward for Euclidean distance. So Euclidean distance here compares all the landmarks, and from all the landmarks, it makes a analysis. So as we move further towards the future, from the same sample, we can get more results from it. So what data source we can use for geometric morphometrics? Legacy data, images from previous research. For those in Ministry of Health or those from service base, if you already have your cells, image of cells, images of bones, CT scan, MRI scan, you can use those for research. You can also use real specimens. But real specimens, the problem is you need a lot, or if you do not have a lot of specimens, you need to rely on a very peculiar issue, or for example, a very specific disease or condition. Then you can use a very small amount of samples. So 2D images of specimens, surface scans, microscopic specimen, 3D models. So the example is actually quite a lot. So what geometric morphometric does not tell you is the difference, large or small. It cannot tell you whether this is big or small. You need to do the inference based on yourself. It does not tell you are there any errors in the landmarking. And then it doesn't tell you the groups of organisms. So you need to define what you are looking for and do analysis based on that. Also, what cannot be conducted with geometric morphometrics? Basically, almost all 3D objects and 2D objects can be measured with geometric morphometrics. The only thing which cannot be measured is liquid. So liquid, because it doesn't have a fixed structure, you cannot measure in geometric morphometrics. So if you have a cell with a cell wall, and the shape is always similar for that kind of cell, then you can measure. But there is an object, for example, a 3D object which does not have, or 2D object which does not have definitive landmarks. A 2D or 3D object which does not have definitive landmarks is, for example, a circle or a oval. Pringles, for example, here. So this is your Pringles here. So Pringles is a 3D object. You can touch the object, but you cannot measure a Pringles because you cannot tell from the Pringles where is the head or the tail. Because when we are going to landmark, we need to determine what is head, what is tail. Where do we start and where do we end? So a Pringles you can put is an object with two symmetries. So we cannot measure this, sadly. We can try to measure, but we cannot get meaningful data to interpret. So when we're looking at the conventional techniques and looking at the Foley's method for stature and estimation in 1956. So this is from the Foley method here. This picture, the bone here, is from his paper here. So linear measurement of the femur bone here. We can see that the analysis here, it gives you a linear measurement. So you can plot the data, it gives you the p-value. And finally, what we want from the data is we want to extract the what we call it, we want to extract the stature analysis. So this is for the stature analysis for the fully stature analysis. And this stature analysis is still being used today for stature analysis when we're dealing with human remains. For example, what geometric morphometrics can do is that we rely on your CT scan data. So we landmark the data, the bone, the same bone we landmark again. What we can do is that we can see we can get a lot of items. We can get the original line measurement on how the growth of the femur. We can get the principal components. We can get the we can subclass based on we want to analyze either the femur head, the distal or the proximal aspects of the femur bone. We can classify based on race, sex, or age, based on the demographics of the person. Other analysis from the same CT scan, but we are not using geometrics. We are not using other analysis. We can, from the same CT scan, you can do, you can use a software to see the bone density, for example. And bone density is important for bone stress research analysis and to see malnutrition. So you can see bone stress. And you can see also the angle of some bones which require analysis. For example, for some surgeons, when they are doing a lot of surgery, for example, carpal or tunnel syndrome, whatever, when doing a lot of surgery in the wrist region, based on their experience, they can tell that immediately if this person has this kind of bone shape, this person in future will develop this kind of injury or this kind of disease. This is just based on experience and not based on other items. But in order to test the experience, you can use the software to see the test. So this is an important why we need to keep data. So importance of raw data for going forward with new methods is all because there will always be methods for future analysis. Either you rely on virtual data, either CT scan or MRI, or you rely on your physical data, photograph, or from your slide projector. Medical schools have a lot of slide projectors. Have this slide specimen where you put in your slide projector. For those of you who are my age and older, you have this slide projector, you put here and you next slide, you put it, the machine will go prop inside the machine and the projection will show light. There are a lot of specimens, cells, mostly cell staining on the projector here, which you can use now for analysis, provided we scan it. And your face photograph, if you already have a lot of database previously, we can still use the old data for new analysis. And this is the importance of raw data and the importance of proper upkeep of raw data. So for the conclusion, I'm going to talk about the funding, publishing, and other issues. Funding. So nowadays, funding plays an important aspect of research. So high costs associated with new equipment. So 3D scanners are not cheap. Example of the 3D scanner picture I showed just now. A good 3D scanner will cost about 100,000 ringgit for a scanner. That doesn't include the software or the computer parts included with it. And then if you do not have the scanner, find researchers in other fields which have the equipment. Malaysia, we have all the equipment. It is just a matter of finding the right people to connect with. So if you do not have a 3D scanner, find a researcher which has the 3D scanner. Similarly, if you do not have the photogrammetry, you can do it by yourself. If you do not have the expertise, you can reach out to other people. So for those who are in the service-based field or working in service-based for a Ministry of Health or hospitals, they will not have time to do all these things. But if they can just talk to other people, the people in the universities are more happy to be collaborators with their work. So, and then national grants or international grants nowadays, we are actually prioritizing after Vision 2020. So last year was the last year of Vision 2020 for FRGS, for those who know the fundamental grants. Our focus now is the 1010 or MySTIE, which is the Malaysian Science, Technology, Innovation and Economy Framework 2020 to 2030. So last year, the Ministry of MOSTI Dr. Khairi Jamaluddin, put this framework for the next 10 years. So for the next 10 years, we are dealing with MySTIE, and also for the next 10 years, we are dealing with the SDGs, or the Sustainable Developmental Goals. So everywhere you go now, you will hear about SDGs, whether it's sustainable or not. So this SDGs is actually a priority of international priority area. So funding. So there is incentive to work cross-field. Do not just be in your silo, in your area only. And then funding is also needed for honorarium and service. So when we do talking about publishing, so publishing, it can be either human or animal samples. So when we're talking about publishing, you will require ethical approval. Humans, yes, all human-based research require ethical approval. Animal depends on the type of animal and depends on the state of the animal. If it's acquiring dead animals from zoo or whatever, then you may not require ethical approval, but you still need to check with the relevant authorities so that just they note and they've given a certificate regarding the study. And then there is a more incentive to work between fields because of cross-field research. Because when you are working with cross-field research, you can publish in higher impact journals. And publishing will take years, maybe months or years after initial data collection. So do not worry. And it is easier to publish for case studies. If you have a case study, which is very rare, you can publish immediately. For example, COVID-19. When it first started COVID-19 last year, what happens was a lot of publication came about for COVID-19. Now, this year, it is actually harder to publish about COVID-19 research compared to last year. Last year, it was novel. When if you have a COVID-19 based research, immediately it will be given to priority publication or instant reading or whatever, or very quick access towards publication. Now, COVID-19 is no longer novel unless there are breakthrough findings. Other issues regarding your research is that data access, either conventional or new methods, is the sampling. Because we are now living in a COVID-19 environment, localized sampling is harder now. Previously, people from outside the industry, from universities, can just write to the hospital, a university hospital or just government hospital. I want to do research. I want to collect data at your government hospital at this region here from a certain time to a certain time. So the government hospital will issue, yes, feel free to do, feel free to come this time at this time to collect your data. Now it is harder because of the COVID-19, and hospitals are all very much busy treating COVID-19 patients. Pretty soon, I suspect there will be a vaccine passport or vaccine green zone, where if you do not have your 2 shots, 2 immunizations, inoculations, then you cannot visit government or private properties. And then political implications. Data access from political implication, when we're talking about ancient human remains. For Malaysia, this is not much of an issue because aside from Lembah Bujang and Guania, we do not have a lot of very old human remains. Ancient human remains is mostly a European thing and an African thing. For example, Egypt, there are a lot of ancient human remains. So politically, there is some political hurdle you may come about when you want to get towards the sample. And then political implications about repatriation of specimens. So repatriation is more of a service base. Malaysia, we are not involved in this kind of repatriation. Usually United Nations and people who invade other people, first world countries, for example, when they send troops to another country and the troops die in that country, they need to repatriate the deceased. So repatriation of the deceased, for example, of army forces in Kosovo and Bosnia during the war in the 1990s. So the war zone repatriation is one issue. And then we are now dealing with security of a new data, or security. So security of data, of your virtual data, is now very much important because there are a lot of prevalence of hacking, and hackers have not yet targeted Malaysia. And I urge you, for those of you who are in the Ministry of Health, if you are in a position to implement higher or strict security measures, please put those security measures in place, because nowadays hackers from a certain Eastern European country are attacking United States hospitals, not only hospitals, United States infrastructure, to and then held the organization to ransom. So because the hospitals or the whatever organization needs to pay the hackers, usually in cryptocurrencies such as Bitcoin. So and the hackers will give the hospitals back the key to unlock the data, and the hospitals and the institution can get the data. So these hackers are already attacking a lot of US and UK institutions.
Can you please mute one of the participants?
I have died every day.
Dear participants, dear audience, can you please mute?
Okay, so back to that now. So hackers are actually now targeting US and European hospitals, not only hospital, institution as well. Malaysia, we are not yet on the hackers' radar, simply because our currency is not as valuable as US and European currency. So pound, USD is more valuable, and they are richer. So they are targeted. So if you're in the health-based field, or if you are dealing with very sensitive data, I would like to suggest that you try to secure your data. Talk with the providers, the equipment providers, Siemens, LG, whoever is providing equipment to the hospitals. Ask them what is the security of the database, the PACS database. Is there any security? Can this be hacked or not hacked? Because this is a big issue. Our issue now in Malaysia is just not hacking, it's just downtime, server downtime. When the server is down, people cannot access the PACS database to see the bones or whatever items collected by the PACS database. So, and then there's another issue. A leaked database cannot be used for research. If the database is leaked for everyone, and if the journal knows that this data has really been leaked, then your research is null and void. So that is all for me today. So hopefully I've given you some examples on the new methods for forensic anatomical research. So if there's any questions, feel free to ask me. That's all. Thank you.
Thank you, Dr. Hilmi Hadi, for the excellent presentation. Now I would like to open the floor for Q&A session. If you have any question, please either turn on your microphone or post them in the chat box. To start off here, Dr. Hilmi, I think one of the most recent advances in forensic anthropology is on the DNA recovery and analysis from skeletal material. Now, what is the current scenario in Malaysia, and do we adopt NGS and MPS, for skeletal profiling? Is there any studies being done?
It depends on where it is coming from. If the body is a post-mortem body brought by the police to the Ministry of Health, usually to the forensic pathologist, the police are only interested in getting the most information from the dead body. So how he died, what is the cause of death? Usually it's the cause of death. The police just wants the cause of death. The forensic pathologist will do whatever he needs to give police the cause of death. So and the forensic pathologists do not want to keep the body in the hospital for a long time, because families will want to bury or process the body immediately. But for some hospitals, so you need to, for forensic pathologists, they need to collect data at that time. They do not do analysis at that time. They just collect everything they have at that time. So what they do is, for research later on, is they will see back the DNA. So if it's a DNA, if your question is specifically DNA, PDRM will take samples from the crime scene and give it to the chemistry department. If the PDRM do not get DNA from the crime scene, the forensic pathologist can get DNA from the dead bodies and send it to the chemistry department. In Malaysia, the chemistry department does the DNA analysis, not KKM, not the Ministry of Health. this is because of law requirement. So all DNA analysis is conducted by KKM, by Jabatan Kimia Malaysia, so Chemistry Department of Malaysia. So that's DNA analysis. So it's a case on case basis. If police already obtained the DNA, they may not need the DNA from the hospitals. So they do not need to go on that route. If you are dealing with just skeletal remains, then yes, you need to get it from the bone. Usually we will go from the long bone or the molar region. We will drill the molar region or the long bone to get DNA material for analysis. But for ancient remains, or for example, if you find skeletal bodies at the beach, for example, with a case which a few years ago I was involved in a case where we deal with a body at the beach in Kelantan here. If you take DNA also from the body, we will now have an issue is how do we compare it to, or who do we compare it with? If it's a cold case, if it's already skeletonized, there may not be any incentive to compare it with any database. So that is another issue. Because we need to look at the circumstances of how the body is obtained. So that is the main problem for DNA analysis. So please answer your question. Is there anything else for the DNA analysis?
Just another one. I mean, for you say because they wanted to know actually what's the cause of death, rather than the DNA profiling of the skeletal, remains. But what about? I mean, worldwide. I mean, is it going through? Are we going into that now, or how? Where do we see? Because I've seen you said that we have frameworks for MySTIE. Do you put it? Are you going to have any studies which will look into this in the future?
The DNA database is a very thorny issue. The first issue in DNA database is actually ethical issue. Is it ethically to take people's DNA and store it? That's the first issue. In Malaysia, DNA of convicts are already stored in a database. So if you are in jail or if you've done any crime and you've proven guilty, your DNA is already stored. If you are a normal person, we cannot just, your DNA is not with the authorities. It is not like your fingerprint, your thumbprint. Your thumbprint is captured by the National Registry Department. DNA is not collected yet, and it's not going to be collected because fears of reprisal, meaning people may use the database in future to subjugate some certain groups of individuals. So we do not have. In US, once a DNA is collected, it is stored indefinitely. In Malaysia, if it's collected at a crime scene, it's stored indefinitely. In UK, if it's from a crime scene, it's stored up to 7 years after the crime is committed. After 7 years, the crime's finished, it's already processed, the DNA will be destroyed because the person needs to have his life back. So it depends. So DNA is something it's a bigger issue. It's actually not because of matching people. It is the issue of, from my DNA, you know my race, you can tell what disease I have. And if the insurance providers knows that we have a database, and when they're going to offer you your medical insurance or medical card later on, they will ask for this database. Or they will look at this database. If you go like there are private companies like 23andMe, which you give DNA to them, they say, okay, your DNA, you are this race, this race, this race. You can get atherosclerosis, you can get myocardial infarction, how many percentage. You do not want your insurance provider to know this detail. Because when they look at this detail, your premium should be 1,000 ringgit. Now we have to put your premium 5,000 ringgit because you are prone to get this disease in future. So that is why we do not deal DNA. DNA is a very tricky issue. We do it for a database for criminals, but not for the general population.
Great. Okay, I think we have the next question by Dr. Muhammad Johar Yahya. He asked for the skeletal remains. How do we know the age of the skeletal remains, and can it be done in Malaysia?
We know the age of the skeleton. It depends. either it's a physical or is it a virtual specimen. We know by taking whatever bone, a representative bone or skeletons or a lot of bones from the individual and comparing it back to a database which has already been published. So the database is always available based on whatever database population. So there is a forensic anthropology certification for age analysis. This is an international certification body which certifies forensic anthropologists who are good at age estimation. So how they do is that they will take a test, look at the X-ray. Usually it's just X-ray of a lot of parts. They will look at X-ray of the hand region, the feet region, and sometimes of the hand up to maybe parts of the elbow, and they will look at the fused and articulate region. So because the skeletal, the adult skeletal is 206 bones, but this 206 bone is only for adults. When you are a baby, when you're just a fetal, a child, this has more than 206 bones. The frontal bone in a fetus, this part here, this is the frontal bone on your skull. This part here in adult, this is one big bone. In a fetal or in a baby, this is two bones. When you take a baby, when you press the frontal region here, the top of the head here, this region is very soft because the entire region, your skull region here, is not yet fused. So as you grow older from baby until adult, about 18 years old, all these regions will be fused. And the cartilage will, when the cartilage fuse, so we will look at the fusing and articulate regions of to determine the age of the individual. But we do not do it for one bone. We can do it for one bone, but it is harder. Usually we'll take few bones as references and we will do the X-ray, because from the X-ray we can see, okay, this is fused, this is not fused. We want the inner structure of the bone. Yes, we can be done. It can be done in Malaysia. Yes, it can be done in Malaysia, provided you have the samples and we can just compare it to whatever samples. In Malaysia, age analysis is not that important because we are not dealing with refugees. Refugees go to very rich countries. We are dealing with refugees from South Asian, but they are not remains. For rich countries, Germany, Europe, US, UK, they are always taking in refugees. And when they are taking in refugees, if it's above 18, they will take, if someone's above 18, they come to the country, they will send that person above 18 back to their original country. If it's below 18 or 21, depending on your country, 18, 21 or 16, depending on country, the country host needs to take care of this individual. So the person come from a third world country or running away from a country saying prosecution-based purposes, go to the country, I am 14 years old. So he says he's 14, but the X-ray will prove whether it's 14 or non-14. But usually age is not a much concern. In Malaysia, our concern is mostly race and sex. Because age, but if we have bones for age, we can do, and we can compare back to the database which is already present in current literature.
Okay, interesting. Do we have any other further questions from the audience? Here's another one. How do you differentiate? I mean, the skulls. I mean, you're using the mandibulometer. The difference between the female and male. Can you explain a bit?
Okay, differences between female and male is actually everyone knows how to do this. It's just that everyone does not subconsciously, you know how to differentiate male and female.
Yeah.
If you see, if I use a Malay word bapok, you know that is a male. Similarly, if you see someone, usually a cosmetic seller, a famous cosmetic seller, you know that's a male. But because of cosmetic products, looks very much beautiful compared to the female subject. So how do we tell? It's actually, we look not at one region, we look at the entire skeleton, or we look entire face from top to bottom. Males in general, the most telling feature is that males will have a hump here. So from the side view of my skull, you can see I have a hump here. So you can look back at your husband or your male colleagues, they have this hump here. So this hump here, this is a very male feature. See, when I do this, this is a hump here. And then we look at the nasal or the bone. So we look at the side profile. From the side profile, we look at the nostril, nasion here. If this is deep, this is a very masculine feature. For females, they do not have this, and this one is very shallow. So it's very nice for females. For males, here is high, here is low. So that is just by looking at that region, we can tell immediately. Aside from the mandible can tell you from this region here, if it's very flaring out, whether it's very masculine or feminine in nature. Just because a person, just because a skull is masculine, we do not say the skull is male, female. We say masculine skull or feminine skull. If you're certain, you say it's male or female. Just because the skull is masculine doesn't mean the person was male. Example, if you look at the Maori people. The Maori people, if you look at Moana, if you have no idea what's Maori, you look at Moana. Those people, islander people, all blacks. The females also look very much robust as our Malaysian males because of their body structure and because of their Australopithecus skull. So the Australite skull has these robust features. So it's based on how hyper feminine or how hyper masculine. You look at a lot of features, then you determine this skull, yes, this is a male skull, this is a female skull. But nowadays, the trend is, sadly, our community is going towards a trend where we adore more feminine skull shape. Your favorite Korean pop stars have a lot of male K-pop stars have a lot of feminine features in their faces compared to your normal male skulls, normal male, or what you think of typically male. And in fact, you have more people who like that kind of skull. So we are now going into that direction. So that is the method. But we can still tell, even though that person is, he looks, for example, in Malay, we use the word jambu. Even the person looks soft, have a lot of feminine features, we can still tell that person is still female or male just by looking at the skull. The accuracy is about 95% looking at the skull. If you're looking at, 90% looking at the skull, 95% looking at the pelvis. If you're using the combination of the skull and pelvis, it's 98%.
Okay, thank you so much, Dr. Hilmi. If any of the audience have any further questions that needed Dr. Hilmi's explanation, please feel free to email him at the email address posted in the chat box. With that, please join me in thanking Dr. Hilmi Muhammad Hadi Pritam in the usual manner.